Probability problems often come either in the with replacement category or the without replacement category. Up until now, we've done everything with replacement. This is the alternative. Let's consider this problem. This will be an employment discrimination problem. Suppose there's a company and the employees include 5 females and 3 males, and 3 people are getting promoted. The management says it's all being done completely randomly, there's no bias, everybody is a great worker, but when the 3 people are promoted, they're all females. The 3 males claim reverse discrimination. Is it plausible that just randomly the 3 females would have been chosen? Let's check. The approach we're going to take is to do them one at a time. So what's the probability that the first one is female? That is clearly 5 out of 8. And so we've gotten rid of one of these has been chosen. What's the probability that the second one is female? If the first one has already been chosen, now there are only 7 and only 4 of them are females. So the chance that the second one is female, given that the first one is female, is 4 out of 7. By the same reasoning, the third one, given that the first 2, is 3 out of 6. And what do we do with these numbers? Well, we have to have the first one to be female, and so 4/7 of those situations will get the second female, and 3/6 of those situations are the third female, and as you remember from the earlier videos, of is a clue for multiplication. Likewise, we need the first one to be female, and the second one female, and the third one female. That's multiplication. So I have 5 times 4 times 3, bad 3, over 8 times 7 times 6. Let's go directly to Desmos and figure out this quotient. So our quotient is 5 times 4 times 3 divided by 8 times 7 times 6 is about 0.18. So there's about an 18% chance that if this were done completely randomly, all 3 of the people that were chosen would be female. Is that rare enough to constitute discrimination? At this level, most people would say no. There might be discrimination, but this does not prove it statistically. It could, in fact, just be random. Things that happen 0.18 happen all the time. There's a whole other family of problems where this same principle occurs. And that's when you're drawing from a deck of cards. Like, what is the chance of drawing 2 aces if you pull 2 cards? The chance of the first card being an ace is 4 out of 52. The chance of drawing the second card, given that the first one was already an ace, there's only 3 aces left, and there's only 51 cards left. So it's 3 over 51. So it's this product, 12 over a whole lot, is the probability of getting 2 aces. So when you're trying to solve a problem that has probability in it, and it's a situation that kind of resembles one of these, you have to think, is it like a card where you take it out of the deck and you keep it and then you take the next one, so you've reduced the total pool? Or is it like a die or a coin where you roll it and then you pick it up and you roll it again? You can get the same thing again. You draw an ace of spades, you can't get the ace of spades again. You roll a 6, you can get the same 6. Okay, that should give you an idea of what to think about. We'll see you in class.